All right, so it's time for our wrap up. This was the section about direction fields and equilibria. So the first thing we did was define a direction field, kind of demonstrate how we use that direction field definition to draw one, and explored what we could use the direction field for sort of plotting solutions to initial value problems. We went off and did that example with a website because drawing direction fields by hand is hard. And what's really important is learning what they tell us. And then we moved on to equilibrium values. So we learned what an equilibrium value is, how to find it in this particular example. Oh, wow. Didn't know you could do that. Connecting back to direction fields, which represent equilibrium values, even though we didn't have a word for it before. And then we talked a little bit about how to classify equilibrium values using a phase portrait. We gave the steps for building a phase portrait. This will be helpful to you when you're doing this in your homework, so just remember that slide. And then we did that example using the same differential equation for logistic growth. We found that the equation had a stable and unstable equilibrium value. Kind of talked about what that means, heading towards or away from these equilibrium values that can suck in or push away solutions. And so kind of to write that in a few lines, what you should have taken away from this lecture is how to draw direction fields. And then given a direction field, whether you drew it or use software for it, they're both valid ways to go about this. You should be able to plot solutions to initial value problems. And then we learned how to find equilibrium values. And then and classify them. And then sort of between those two different problems, we looked at the connection between direction fields / equilibria. And most importantly, what I want you to take away from this is going to be, what do both of these tools tell us about how a solution to an ODE behaves? No, that was bad. And so your practice problem for this section is going to be kind of to get at that idea. So what we're going to do is we're going to think about an ODE for temperature T. Of a, let's go back to my coffee. Hot drink left in a cold room. And so just think about, if you start with if you start with a hot drink in a cold room, what should happen to the temperature of the drink? So what should solutions T do over time T? And then using that intuition and what you know about equilibrium values, try to write down a differential equation that would give you equilibrium values that follow that behavior. So try to write an ODE dt over d little t equal to some stuff that gives equilibria. Well, I'm not even going to pretend that it should have to. I'm just going to say that gives the equilibrium behavior you expect. So I'm going to say that one more time in case it was unclear. I want you to think about modeling or writing a differential equation for temperature of a hot drink left in a cold room. Just like, you know what that behavior should be. It should cool down. And then just write a differential equation, d big T over d little t, that when you try to solve for the equilibrium values, it gives you the behavior you expect. There's more than one solution to this. It's okay. Just like make your best attempt and kind of try to really interact with the idea of what an equilibrium is. So work on that. Be ready to talk about it at the start of class, and I'll see you all then.